example of finding the roots of a polynomial function using the remainder theorem and synthetic division. So here's a function that we give you. It's a quartic function, so we can have up to 4 possible roots. So let's start off step 1. Let's find the possible rational roots using the rational root theorem. So we start off with the constant of 18. We list out all the factors of 18. So plus or minus 18. Number of factors are anything that divides by 18 evenly. 9, 6, 3, 2, and 1. Then we take the factors of the leading coefficient, 2. So plus or minus 2 and plus or minus 1. And then what we would do is we would divide all of these. We would take 18 over 2, which is 9. And then we would take 18 over 1, which is plus or minus 18. And then you would just continue. 9 over 2, which is, there goes my smart board, plus or minus 4 halves. I'll leave it as 9 halves. And then 9 over 1, which is 9, which is already up there. And then 6 over 2, which is 3. And then 6 over 1, which is 6. And then 3 over 2, 3 halves. And then 3 over 1, which is already up there. And then 2 over 2.
Jesse Sellers, will you please come to the main office?
And then 2 over 1, which is 2. And then 1 over 2, which is 1 half. And then 1 over 1, which is already up there. So these are all the possible rational roots. Step 2. Use a graphing calculator. On a separate video, I will teach you how to enter in a function into the graphing calculator and then zoom in to find the possible x-intercepts. Remember, we will use synthetic division to prove it. So here's a quartic function graphed out. Notice there are some x-intercepts identified here. So we believe there's an x-intercept at -3, 0. Another one at -3 half 0. Another one at -1, 0, and another one at 2, 0. And then what we're going to do is we're going to start choosing one of those x-intercepts on the next slide with synthetic division. So I'm going to go ahead and just choose +2, 0. So we're going to test let x equal 2. I better write down that other function here. Just give me a minute. So go ahead, and I need the function all right. So let's use our synthetic division. So I'll write our function down here again. So y equals 2x to the 4th plus 7x cubed minus 4x squared minus 27x and then minus 18. So we're going to start with synthetic division, and the x-intercept, so as a factor, it would be x minus 2. As an x-intercept, it would be 2, 0. So we have 2, 7, -4, -27, -18. And we're going to hope that when we're done, our remainder will be a 0. So I'm going to go ahead, and we've done this a lot already, so I'm going to go a little faster. So 2 times 2 is 4. Add 7 and 4 together, we get 11. 2 times 11 is 22. Add it. Multiply. Add it. Multiply. And we get a remainder of 0. So this is telling me I do have an x-intercept at 0. So now I've taken out the factor of x minus 2. My leftovers are now, this is a 2x cubed, 11x squared, an 18x, and a constant. So right now, in factored form, this is x minus 2 factored out, and then I'm left with 2x cubed plus 11x squared plus 18x plus 9. Now we're going to take out another factor. So I'm going to go back to my picture here. We had another x-intercept, we believe, at -3. I'm not choosing the -3/2 for sure because that's not very fun to do synthetic division with. So I'm going to go ahead and do -3 next. So we want to take out the factor. If that was a -3, we're taking out the factor x plus 3 out of there. So we're going to say x equals -3. As a factor, it's x plus 3. And as an x-intercept, it's -3, 0. So when we do synthetic division again, we're now going to go above and use this function here that we were left with. So we have 2, 11, 18, and 9. And when we're done in this box, we should have a remainder of 0. So bring down the 2, multiply, add, multiply, add, multiply, add. All right, we got another remainder of 0. So we're going to drop a degree. This is now my x squared term, my x, my constant. So in factored form, I took this out earlier, x minus 2. Now I've taken out x plus 3, and then my leftovers is this function right here. All right, so I'm going to go ahead and write that down. So my function so far in factored form is y equals the first factor of x minus 2. Remember, that was my x-intercept of 2. My next factor is x plus 3. Then, my leftovers after I took that factor out is 2x squared plus 5x plus 3. All right. I still have 2 factors left in the red. So either you're going to do one of 2 things. You can factor it. And since it's a quadratic function, you could use the quadratic formula if you wanted to. So I'm going to try and factor it. So I'm going to use the AC method and see if it works. So I'm taking 2 and 3 together to give me 6. Set up my chart. What are the factors of 6 that add to 5? That's 3 and 2. So I'm just doing AC method. Group 2x, x plus 1, take out a 3, x plus 1. X plus 1 is my common factor, my GCF, and then I have 2x plus 3. It did factor. So now I have y equals x minus 2, the first factor at x equals 2. I have another factor at x plus 3, and then my last 2 factors in red are x plus 1 and 2x plus 3. All right, step 5 is to actually answer the question, what are my roots, my zeros of the function? So we just set those equal to 0 and solve for x. So I'm going to have 1 at x equals 2. I'm going to have another 1 at x equals -3. I'll have a third one at x equals -1. And then this one here, you need to solve it by undoing. So I'm setting equal to 0 using the zero product property. Subtract 3 and divide by 2. So here are my 4 roots, which are my x-intercepts.